What's going on, YouTube? I'm Peter. This is Lorenz Arrow. Today we are 3D designing a flying car. This is going to be this is eventually going to look like this on the right. Okay. This is the goal. This is a render that I got from passing images of that thing that you see in the back into like an AI enhancing sort of generator. And I was able to use hit'em3d.ai to get a 3D model. As you can see, it's pretty... Actually, before I start, let me just check the audio and everything like that. I apologize, but we'll get back to that in a second. Let me just make sure that you guys can hear me. Test 1 2, test 1 2. I'm like looking over here and not talking. All right, sweet. Hit the like button. Let's get one like today, okay? Yesterday we didn't get any likes, so if you guys can hit the like button, that would be great. Let's get back into the flying car situation. What was I saying? This is the sort of sketch. As you can see, it's not perfect. It's just an AI render, which I was very impressed. Passing pictures I got from the AI enhancing images that I got from that, it was able to create a 3D file for it, like front and back, top and side and bottom, as you can see right there. But it's not proportional, and you can't do anything with this file other than look at it. But it is a good guide or good reference for me, because I tried to get some sort of sketch or anything like that I can copy and put into CREO Parametric, which is what we're using here on the top. You can see we're using CREO for CAD. This is what we got so far. I'm working on this winglet right here. But before we get there, I did want to just say that we are using, for the full scale, these motors. You may have seen yesterday, I took these out and showed. But they're V13L team motors. And I believe they were... I forget how much they were. I'll show you how much they were in a second. The whole setup cost me over 20K. So these are V13L KV65. Focus, there you go. And what I didn't show you guys yesterday is the propeller, which I also want to show you to give you kind of a scale of what these things are going to be doing. These are the propellers right here. Carbon fiber VZ team motor. So this is the setup right here. Okay, so these are the propellers. Dual axle, so bottom and top. They're going to be spinning in opposite directions. But yeah, carbon fiber. I'll show you. It says 40 on it. if you guys can see that. But let me just get these out of frame. All right. That's kind of the deal right now. Where we're headed with the thing is, we want to make sure, because I joined a hackerspace in New Jersey, and we want to make sure that we want to make sure that it flies on a small scale, the proof of concept design that I'm building. So we're building a small scale first. But I do want to show you the price of the motors. V13LT motor. 55 kilogram heavy thrust motors. These guys. $859. Hold on. The ones that I just showed you. Okay. So. Oh man, this. Where do I put the camera? I probably should have figured this out before. I don't want to put it on the CAD software. I'll try to remember that there's a camera here. What's it called? So yeah. So that's where we're headed. Building this small scale first. Let's get into it. Yesterday I was at the hackerspace and I added a few components. Yesterday when I left off, I had this going, not in the holes, but now I fixed it. So the holes aligned. This is the GPS mount. It kind of rainbows over the Pixhawk and is situated away from any electronics because the GPS has a compass on it. So it's very sensitive to electrical storms that the motors, the ESCs, the batteries, all the electronic components are causing. So yeah, we are not going to be talking about the GPS today. I just wanted to update you guys from yesterday that I got this part completed for the GPS mount. I will have to order the stand and actually get the hole sizes and then mount a screw holes into the top of this. But that is pretty much going to be later when I order the stand. And I think I got to order the propellers. I was about to do that off stream, but I got distracted and I forgot that I was doing that, and I just remembered. Today we're probably going to be focusing on the winglet. I started this at the hackerspace yesterday. Just to give you guys an overview of what I did yesterday, though, I did this ESC mount. I need battery clamps. I need a whole bunch of stuff, but I added the HereLink module, which is this right here. So this HereLink module has antennas on it. These guys, there's two of these, which is what you see on the screen kind of floating in the air right now. I could have swore there's two of them somewhere. Oh, the other one's right here. So yeah, there's two of them. One's backwards. And this unit right here, I think is like $1,000. I'm pretty sure. I can check for you guys. HereLink Air Unit. this guy? Trying to get it. Yeah, see? There you go. And it's, I'm not sure which version I'm not sure which version I have. But it was around $1,000. I think I have the newer one. Yeah, I have the one that has a mount on it, because these ones don't have a mount. I think it's, I don't know why mine came with a mount and theirs didn't. But I have the most up-to-date one, and it's around $800 apparently. Okay. I have the Cube Orange flight controller, which is what you saw here. This guy, this orange cube, which is this right here. It's like, I think I have like the $385 one or something. I don't know. It depends where you get it from. Prices can fluctuate, but they're all essentially very similar. So yeah. So that's what this is right here. These guys. This is the HearLink antenna that I was showing you. I don't know if my CAD file, my CAD program is able to do wiring. I was thinking about creating wires for demonstration purposes. Oh no. I think I pressed something that like made it. I think I pressed annotate or something. And now it's like blue and stuff. How do I turn this off? How to turn off annotations on CREO 12. You can try to disable the planar annotation box under home filter, model filters, home filters. Wait, what? Model filters. I could just like X out of CREO and restart it. But I kind of want to know how to do it without doing that. In the graphics area or the figure content pane of the upper data panel, right-click the annotation and select hide or unhide. In the graphics area or the figure content plane. This. Right-click the annotation and select hide or unhide. Maybe if I go to, it should be an annotate, right? Like if you're gonna put something that annotates, simulation object, there you go. Oh, it's live simulation objects display. It's not even annotate, it's live simulation objects display. What the hell is that? That's cool. You can like put physics on it, I guess. Anyways, back to what I was saying. What was I saying? Um, let's see. Um, oh, I was talking about the cables. Oh yeah, I was talking about cables and then I pressed live simulate. I wonder if you could do cables on this version of CREO. Um, cabling. I found it. Create a special cabling harness part within an assembly. I wonder what happens when I press that. Well, this has a cable. I wonder if I press like this and this. How to create how to create how to create cabling in CREO 12. Manual cabling process. Excuse me. To create a wire cable, after creating or activating a harness part, click route cable. Click to create a new wire, to create a new cable, or to create a new ribbon cable. Click route cables. Route cables. Where's route cables? Create harness, modify harness, create harness. Okay. Motor to ESC. Lorenz. Okay. Hold on. Maybe we need to watch a video. This guy's pretty good.
In CREO Parametric, you can perform manual routing of cable harnesses. I created my original manual routing video back in CREO Parametric 6.0 in 2019. Here I am, it is 2023, and I am in CREO Parametric 10.0. I want to show you how to perform manual routing today with some of the enhancements to cabling in the past few years. Here I have my assembly open. In
Yeah.
another video, I showed top-down design techniques for creating a harness subassembly and a skeleton model containing a couple of shrink wraps for the necessary geometry for routing my harnesses. Let's open up that harness in its own separate window so you can see my visual references. And at this point, I want to bring in the connectors for this particular harness. Before I assemble them though, let me open them up. I'll hit the open button and let me navigate to the folder that has them. I'm going to grab some D38 other different to unclutter the screen. Let me hit the assemble button and I will choose the eShell connector for going over here. And once again, I am selecting a cylindrical surface and then a flat planar surface. And then for the other one, a vertical surface. Now let me hit the flip button. I don't really need to flip it, but I sort of like having it exactly the way that I want. So that's good for the first one. I'm going to throw in 3 more. Since I have a component interface, I just need to hold down the right mouse button and choose new location. And then let's choose this and then zoom in and choose this surface and then this one for orange wires.
Does this guy actually create wires or no?
Build a, I know that I'm going to need to, I will select
I want to see you make a wire, bro.
surface, this button. So I moment for all the harness under appearances file of point one system.
I
But
think these
I
are.
did to that the entry port or
Oh, I
entry or
see.
exit. It is proceeding
I
through
see the wire
five
now.
buttons. Okay, so that's good for that. Go to the since I made that so inside of
Oh,
here we can see
nice.
the wires that are in there and the entry ports that they route to and from, as well as the reference designator notes that are associated with O video.
Oh,
If
so
you
you,
take a look in
hold
your
on.
cosmetics section, there are a couple other different for that one.
Okay,
And
so
for the last location for the
all right, so he does create wires. I'm gonna have to study this off stream. I don't wanna bore you guys, and like I guess I could learn on stream, but I feel like I won't get as many views. And I want to get my 4,000 watch hours. So let's just go back to doing stuff that I already know how to do. But that's good to know that I have the ability to create wires, because I do want to do that in a future stream. I'm just going to keep this like that. That's actually a better idea, because now I know that this area is off limits. Literally just have a blank spot right there. I can actually put, yo, you know what I could do? I could put OBS right here, bro. That's crazy. That's actually crazy. I'm like a genius right now. Wow. Hold on, let me do this right here. Okay. I'm like improving my stream every day. Well, this is all right. Let's get into it. All right, here's the winglets. Here's the Hearlink antennas that I need to create wires for, because I need to figure out these have to be at 90-degree angles, which is why they're not proportional. They have to be like a V, because if the drone is going to turn away from you, the signal might get weaker on one antenna, so it switches over to the other one, kind of thing. And so it's either they have to be like at 90-degree angles to each other. I don't know. I was reading something about they have to be at different angles. So I might leave them like that or whatever. And then the wires will come through probably like a hole right here I'm going to create for either one. I'm going to create a hole for them. And then that wire will just kind of like I'll do some cable management, put some clips right here, and insert it into the Hearlink module air unit thing. So that would be a whole separate thing. So I want to make this winglet now. That's what I was kind of doing at the hackerspace, and I feel like that's a pretty good thing to do today. I think I have to model like some of the components in here, because these are the electronics. Like this guy right here. This is a buck converter, so it steps down, like it takes a high voltage and like steps it down and makes it a lower voltage on the output, so it can power like my low voltage components, like the flight controller, the Hearlink, etc. Oh, and I'm putting LEDs as well, which is, oh, and that's the last thing I'm going to talk about before I start, which is this guy, the power distribution board. It's going to be like a small circuit for low power, um, stuff. So anyways, let's get started. This guy, oh man, left, right. Let's do it this way. This guy needs to be extended a little bit. Hold on. Because Because I'm gonna show you. I like to show and tell. This guy needs to be longer because this guy right here. Oh, my computer is processing. New to CREO simulation? No, I'm not. This isn't even CREO simulation. This is CREO Parametric. Contact 720 failed to generate model. Can we delete this? No. Contact 720 failed to generate regeneration model. Oh, you know why? Close that. That's why. Okay, so if you look from the top, right? These airfoils, these not airfoils, these propellers, these fans are going to, I don't know if it's too loud or what, but this needs to extend out like this way. If you see my mouse, it's gonna like circle around this and then like end right here and then curve in. So I need to add a curve, but at first I'm going to add the extent of this whole thing. So I'm just gonna create one file for it. Trying to think, and then I'll chop it up. Trying to think. Yeah, that's what I'm gonna do. So I had to extend this out a little bit because this part needs to come out like that. Okay. It's hard to explain visual concepts in language, but I did my best. So let's create like I don't know how long it is. This is in inches. So I believe maybe 24 should be sufficient. My computer is two outdated placement features. Component ID winglet front. Yeah, delete that. What other is outdated? Component winglet front. This guy? Oh, okay. I see. Let's unconstrain. That's probably why it's like my computer's like freezing up. So yeah, let's center this. Let's center this on the datum plane in the middle. I guess we can use let's just use this top GPS guy. Okay. Wow, my computer is like contact 720 failed to regenerate. What does that mean, bro? Motor to ESC. Maybe this guy needs to get deleted. Why am I getting that message? Every time I do something, like my computer like lags. But okay, so it's gonna need to be a little bit further, like to here. So we can probably make it 26, I would say. This thing's gonna be a beast. It's gonna be pretty big. Let's do 26. 26 inches. Wow, my computer is like... Is it this guy? Let's just delete this guy right here. What is contact 720? It's not giving me any more information. It just like... I don't know. That's probably plenty of room, right? The green is kind of the outline of it. So the ducks will be surrounding this thing right here. Now we're gonna move on to the hard part, which is putting these shapes onto... I did this earlier. I outlined this guy. So you see how the cabin kind of like curves here? I'm gonna need to paste that curve in the exact right spot. And for that, I'm going to need the distance from here to here. Distance from here to here. 1.0437 inches. Okay, so just paste it there for now. And sketch, I'm gonna need to copy. I believe it goes like this. So I'm gonna need to copy all this right here. Sketch on here. Paste. And it's like something like that, I believe. I think it's something like this. Radius is going to be 1, so that changes things a little bit. From here to here is this guy. Okay, we probably don't need this guy anymore. And from here to here is 0. And I think that, and let me just do that. Add an extension because we did extend it. And now if I extrude this, and that should be sort of the, let's see if I got it right. Yeah, I think I got it right, guys. Well, this top part is inside a little bit, but this edge is perfectly on, like, constrained from here to here. Um, see, this cabin. The cabin is the outline, and it sort of hugs it on the edge. I'm gonna need to extend the tip of the nose here so that it fits perfectly there, but contact 8. Oh, these are a lot of errors, dude. Failed generation. Contact 88. Hold on. Okay. Datum planes will not be displayed. Select references for measure summary analysis. Advanced measure analysis completed successfully. Contact 278 failed regeneration. I wonder what that's about. Because every time I open my computer, like, heats up, my fan starts spinning, and something's off about this. I don't know what it is. Anyways, so yeah, let's finish doing what we were doing here, which is taking this, mirroring it over this, so it's like that. I wonder why it's like. Why did it cut here like that? Why is this like out like that? I have a full extrusion, and then it like becomes straight here. Am I like high or something? What the hell is happening? You guys see that, right? Like, why? What's causing? I swear there's someone with evil eye on me, bro. Like, this never happens to me. Actually, that's probably a lie, but probably does happen to me. I guess I'm gonna have to manually like create like no, that's not gonna work. Maybe. I'm so confused. This gets extruded. There are no other items in this bar right here that would cause. Oh, I see. I see. I see. Okay. I see. This is too. Sorry, I said you guys are evil eye. My bad. It goes like that, and now that should be gone. Yeah. All right. Um, now this is annoying, bro. Can you tell me what that means, bro? And it's like more and more are being failed. Let me just put this into into Google, figure out what's going on. CREO. Like results from a circular reference or broken external reference. To fix this, open the model and check for and resolve any circular loops and constraints or references, especially those involving copy geometry or other external references. Oh, you know why, maybe? Um, this winglet, is this constrained? Please tell me it's constrained. Yes, it is. Okay. Select any reference. Does that fix it? No. If the issue persists, try regenerating the part in the assembly, checking the model tree for failing features, or submitting the file to PTC CREO. There's nothing failing here though. Like it usually shows up as like something, you know. Mannequin maybe? Let's watch this video. Check for circular references. Open the assembly.
Or have hundreds of parts, but don't know where the issue is. For this example, I have this bracket and pin assembly here. I know it's not hundreds of parts, but the idea stays the same. To find the fault, just going to regenerate. I'm going to click on our notification center. Click again on the circular reference. And this is where you will find a list of circular references in which assembly or sub-assembly they can be found. Left click on the one you wish to resolve. We only have one here, so I'm going to select that. And here you have two options. First one being the circular reference report or the reference view. Now I'm just going to show the circular reference report. This is like a log file, gives you the feature number, and it's found in which ID of part or assembly. It just gives you a list of names essentially with the feature ID. I don't typically like using this. I prefer using the reference viewer, as it can highlight the components and features in the reference viewer.
How'd you open that window, bro?
As it can highlight the components and features in question instead of just giving names. But with the reference viewer open, we can navigate to the paths tab. And at the bottom here, you'll see a list of circular paths within the assembly. As I select that, you'll see on the right-hand window some names at the top. And by hovering over the items found here, you can see the part and feature highlighting or indicated here with a highlight, that's found within the circular reference. So in this case, we have the second part, and at the bottom here, you'll see a list of circular paths within the assembly, components and features in question. I prefer using the reference viewer, as it can highlight the components and features in question instead of just giving names. But with the reference viewer open, we can navigate to the Paths tab. And at the bottom here, you'll see a list of circular paths within the assembly. As I select that, you'll see on the right-hand window some names at the top. And by hovering over the items found here, you can see the part and feature highlighting or indicated here with a highlight that's found within the circular reference. So in this case, we have the second
You
part,
have not
which
checked
then
the
open,
out the license option,
referencing
file
the
options,
extrude line
floating
feature,
licenses.
which then references
This
report
is the
1
free
feature,
version of CREO. Why
which
do I
is back as it was the starting block for the pen.
currently accessible?
It will take some time to understand how to read this window, but basically, let's say I select the pin component. On the left, you will see the parents, and reading from top to bottom, we can see that the component was placed using references such as the assembly top plane, sheet metal extrude, and extrude cut. These are references from the assembly and the first part or the bracket. Then we have the top plane and x-axis from the pin, as they were used to constrain the part into place. But at the bottom, we see the extrude feature from the pin component listed as a parent. This is the first sign that something isn't right. We can do the same for the other features in the pin component, and you'll notice that
Maybe if I just restart CREO, it will, let's try that. I don't know. Desktop, users, Peter, downloads. Okay, I think that error went away. Let's see if I go here. Yeah, I think that fixed it. Whatever was going on. Let's get back into it. Sorry about that. Now we need sort of like if you look from the top, we need ducts. Like these are ducted fans for like protection and what else? What other benefits of ducted fans? It just protects, it's mainly for protection. That's what I'm thinking. It also might influence noise pollution, like dampen sound pollution or whatever. That's a pretty good idea for it. So yeah, ducts. I'm doing ducts. This center line to here is a certain distance, and I just like how I had this ready for you guys already because I did it yesterday. I have that right here. So I think it's this way or that way or something. I don't know. Let's do that way. this guy like that. Let's sketch on the top plane. Go like that. Ratio it. And let me just make sure that I'm getting this right. I think this might be like that. Wow, so that line does not tell me anything at all. I was hoping this line would line up somewhere. But it's all right. I mean, we have the sort of idea behind. Actually, you know, we could probably just, we don't have to do it that way. We could just remake the circle coming from well, they have to be placed a certain way. And the placement is going to be in the center of this line. So if we turn on an axis, this guy needs to be, and that's why there were points and stuff. Okay. So let's create a point. This and this, we can create a point here. Nope, that's not gonna do it. Okay, why did I press undo? We need to create a point so that, that's how I did it yesterday, is I created a point from with this line and this line. So if we take this axis and this curve right here, we need to create a point. But the point is not, the point that gets generated is off. Like it's not directly. It needs to be like right there. I wonder why it's doing that. Because if we create a point, then we'll be able to put that point onto the sketch with respect to the distance from here. Wait, why am I doing it? Why am I doing it the hard way, bro? You could just go like this. You can view from the top. Winglet front, we need this guy. This center line. This edge. this center line, this edge. Why can't I create a... Okay, so there's the point. And then we need a point right here, the center of this motor. Okay, maybe not a point, but a line. Can I create a line? Okay, so this point and this line are a certain distance. Okay. But this point needs to be a line as well. So then I can measure the lines from one line to the other. Okay, so let's create a line with this point, with this point, and this plane. This plane and this point. Okay, so I'm trying to select this point and... Well, what's the measurement from here to here? Let's start there. See, we know the distance, so I'm trying to create a parallel line, like a 90-degree angle from this line, and this point needs to have like a line going this way so that I can measure this horizontal line against this vertical line, and that will give me the nearest distance. And I'm trying to figure out how to make a line, and I thought I could just click on a point and click on a plane. But you know what I could do? Why am I doing that? I'm such a dumbass. You could just make a line like this. It doesn't necessarily have to be that point. So now this is the center line, I believe. It looks center. And then take this line and measure the distance. 8.6493. Okay? So that's the magic number right now that we've been after for like 5 minutes. So now we sketch on here and then create a center line here, which is going to be the center of the duct. And look at that, 8.84 was my guess. It's actually 8.66, whatever that was. So now this is our duct right here. And it has to be 7 inches because the propeller is 7 inches. But you know what? That's wrong, because this center line now is not the actual center of where the arm is. So to get the center of the arm, we can take a measurement again. But I'm going to need that. I'm going to need this number. So let's go there. And I'm going to need that number. So from here to the arm, which is over here. So we can take that and this analysis. Huh, it's 0. I wonder why that is. This means that these lines aren't parallel. I don't think I constrained this winglet. Oh, I didn't constrain this winglet. Hold on, let me constrain it. Like that. And now, if I measure from here to this guy, 4.16734. And I believe that's the correct measurement. So now we have the measurement for the center line of where this guy's supposed to be. So from here to here, from here, this edge to this center should be this number, which is that. See how it's different? So now we can go back to this number, 8.6 whatever, sketch a point, put it on this line, and this should be the center of the duct. So now we can safely put, let's say 7.6. We can give the propeller some room from the wall so that it can spin around. 0.6 inches. 0.6 inches is about that big. So that's how much room is going to be inside of the duct. We could probably put that down to like 7.5 or 7.4 to make it like really tight. Because this is where the duct is going to, this is where the propeller is going to be spinning. So it needs like, I'd say like 0.4 to be safe. So we could do 7.4. Okay. Let's see where that got us so far. Remove. So now the propellers should be visible. Nice. Okay. And we can clean this edge up as well as this edge. There's going to be like a tangent line coming from this circle to here. So let's go ahead and start that. We can literally take another sketch here and actually we're going to be on this guy. So in order to create like we need to cut this part off. We need to cut, and then we need to cut this part off. And then we need to cut this part off. Oh, wait. From here to here. From here to here. Whoops. From here to here. Okay. And then I wonder, we could probably do that. And then you see how this circle is like highlighted? We need to make this highlighted. This part, this entire thing right here needs to be highlighted. So this circle needs to get cut. Because right now this isn't a shape, this is like a line thing going on. So you know what it is? We can delete this right here. There you go. All right. So that will be sort of the ducted fan curvature situation. And I don't like how it's like flat like that, so I'm going to create a curve. It's gonna like, you'll see. It's going to I don't want to say you'll see though. I wanna explain it. So this curve right here, it's going to be like a tangent line from, I would say, like about right here. We could probably do like a very sexy like angle. 33.3 369 33.3333333. Okay. And then I wonder what that would look like. Like that. And then from here to here. Or actually, should it be right here? So we'll take this spline. Go like that. Like that. So that would be kind of the curve. And we need to get rid of this part here. So just like we did before, we have to figure out where to cut the circle. Actually, we need to create this circle again. We could do a construction line. Construction line here. And it goes to this point here. So this construction line and this can create a point. I think I might need to create this circle again. Like actually, not a construction line. My mistake. I think it's supposed to be like that. And then we could delete this right away. Okay, so we can delete this. And we could delete this guy. And then go like that. Or, so that was right, but it's not. Oh, you know why? Because this guy's here. Okay, now that's good. Nope. Nope, 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 nope. It looks fine, right? Like, it's highlighted and everything, so I'm not sure why. That didn't work. It's the right idea, though. Let's go ahead and delete these lines. Let's just get it back to how it was. Then we'll start again. Okay. Really, that didn't work either, huh? Oh, because there's a line right here. Okay. All right, but let's start with this circle. And then make the sexy angles based on this situation. So just like before, we're going to use a center line. Then we're going to make this tangent. I feel like that might be... Okay. And then we'll go here. And we'll go tangent to there. And then we'll take a spline. Like that. And then we'll go like this. Like that. And now we can just delete all the things that we don't need. Which is, we don't need this guy. Actually, yeah, we do. We don't need this guy right here. Okay. That should work. Yes. Okay. So that gives it sort of the... It gives us sort of like a... It's based on this image right here. Let me show you guys. Oh, did I show you guys the unveiling?
Born from the wind and sculpted for the sky, every contour, every surface shaped for glide and lift. 4 intelligent ducted systems converging in a dance of thrust and precision. This is...
But you see how it's like curved right here? It's like curved from the center. I think this might be a little too much. I think it should come from the center here, though. So that angle stuff that we were doing, it's kind of... It should be from here, from the center. So let's undo that. I was kind of trying to, I guess, like, put my own signature on it, but we could still do, like, okay, so I guess now the question is, I guess it's like that. I'm trying to make it look like this guy as much as possible. The only question now is, will this be able to be 3D printed? Because it's very thin. So I'm thinking probably we can probably get rid of this. We can probably get rid of these guys. And just remove material. So that way I have something to attach it to. Okay. So that's kind of the look behind it right now. So yeah, I'm gonna make like, you see how it has like 3 ducts, kind of like the airflow is gonna go through here. That's how the one in the back has, it's like there's space in between each airfoil and the air goes through. Let's paint this guy. How long have I been streaming? An hour and 20? Okay. Okay. So gonna need like a little extension here to like screw these into it, and there's also a gap, so I'm gonna need to sort of fix that real quick with these rectangles. I keep messing up. Oh, it's not like a perfect. Hold on, let me make lines. It's not a perfect rectangle. It's like curved a little bit. Okay. And this guy needs it as well, because I used a rectangle there, so let's use a line. And then let's just extrude it a little bit. Oh, but it's curved here. No worries, we just need to curve it. We're gonna take this spline here and sort of just curve it like that. And we could erase that. Okay. And we can mirror this over this guy. Okay, so there's a gap now. It's not hugging the wall, but that would pretty much be I don't know. There's probably a good practical use for that somehow. Like a tab or something. I don't know. Like you can screw something in there. I don't know. Okay. Anyways, just ignore that. I would have to like retrace this and then copy and paste it and then create like an actual curve. Or I can just guess and check until it's like pretty good. Like if I just do that. I can probably move this in a little bit. Because that's the center of it. So I'm gonna need to create a new spline for it. Now it's inside. So still inside. Still inside. That's pretty much the same gap from here to here. Actually, that gap is very tiny. That's a tiny gap. And now I kind of just have to like that. Very close, very close. We're almost there, we're almost there. Perfect. All right, perfect. You can actually see it from the bottom too. This bottom piece. Oh no, it's actually inside now. I think that's just because, like, perspective wise. It's a better view from the bottom, actually. You know that Leonardo DiCaprio? I think it's called like Ho- Hollywood or something. Something about Hollywood. No, that gap's too big now. But he's like, and he like points at the camera. He's like, pointing. He's like spotting something like suspicious. That's what I imagine every time it's like off a little bit. I just see like that meme of him. Okay, so this part's good. It's just I'm going the opposite way. Um, you know what? It's like just that bottom part is like the rest is fine. And even on the top, there's like a gap. So the top and the bottom aren't aligned. So what I do to one part is like it doesn't match exactly. Um, this guy needs to be like a tiny bit like that. I think that's pretty much as good as it's gonna get. Is this even aligned here? It looks like it, right? Okay. Curves and stuff, like, when you're designing, you kind of want to have like boxy shapes. Um, like boxy shape, like squares, like 90-degree angles. I like 90-degree angles, like. But when you start like putting aesthetic stuff, it becomes very annoying. But I am going to have to build off of this. because all of the curves are on this already. So good thing this is a flat surface. I could just kind of work off of this. So let's go ahead and create like a okay. Actually, this is a straight line from here to here. And then we're just extruding this. Oh, wow. Okay. Circle. Circle, circle, dot, dot. Now I have my cootie shot. Circle, circle, square, square. Now you're gay everywhere. I don't think that's how it goes. Whoops. Perfect. Now we can just take this entire thing, mirror it against mirror it against this guy. Extrude. And that will kind of be the base sort of model situation for this guy. So let's go ahead and measure. Oh, this is not flat, is it? Distance. I wonder what this guy needs to be on here. Coincident. And this needs to line up with that, with the little gap here. You guys see this gap? Has to line up with the top of that. So actually about 2 inches. Maybe a little bit lower. Yeah. 1.97. That's fine. Now when I measure the distance, of this guy from here to here, 6 point, no, sorry, not that guy. from this guy to the bottom of the floorboard. I just got to make sure that the floorboard is actually the lowest part on the drone. Which it will be. I'm going to make damn sure of it. The thing is, this is not... Oh, I see the problem. Okay. Actually, do I see the problem? You guys see how it's like tilted? Huh. That's strange. You know what I can do though? Is I can... No, that won't work actually. Huh. That's strange, man. I thought that was a flat surface, this guy. Oh, you know what it is? I can make it. Okay. Here we go. Here we go. This fixes the problem. Let's go from here to here, and from here to here needs to be like that. Then you go like this. Delete this. Okay. And now this guy needs to be on this. Okay. Oh no. Hold on. 3 outdated placement features. Winglet, outdated placement or feature. What is that? But wait, what did... Okay, hold on. Oh man, I think I just broke it. I can't even X out of CREO now? Hold on. How do I update the reference for this? You haven't specified enough references. Yes. Highlighted vertices are very close to each other but not connected. It may cause trouble in creation of future geometry. Do you want to add a same point constraint between the highlighted points? Yes. I definitely want this guy though. Oh wait. No, I need part CSY definition edge. Can you guys even see what I'm doing over here? Okay, plane this guy. Okay. We still got this guy. This guy was the hardest part. But he's placed on the wrong thing, I believe. Oh no, he's not. Okay. We still have that. How does that look, by the way? Not good. Not good. Not good. All right. Oh, we can probably. This guy got messed up. This guy. can literally just be copied, I think, from here. Hold on, let's cancel that. We do need this. Although it's like pasting itself upside down, because I think I did it upside down. So when I paste it onto the sketch, it goes upside down. Like that. Huh. Okay. So I can delete this. Paste it. Do this. And then sort of align it with this guy. I would like to find the center line. From here to here should be 0. Oh wow, that messed everything up. Let me try to... No one's watching this because it's like ridiculously difficult to... Maybe in the future someone will, but man. Datum plane. Right datum plane. Right. Alternate. This is really difficult, man, cuz I might just redo this guy right here. You haven't specified enough references to place this section. Sketch anyway, yes. This guy can get deleted. Because the only thing we're really missing is this curve here. So I just have to make it. And I think I created like center lines or something. From here to here. Oh yeah, remember that? Okay. From here, I think I just randomly like created something like off the top of my head. It wasn't anything specific. That's why I forgot how I did it. Because I don't remember stuff like that. Alright, there we go. Alright, we got it back. Okay. Now, how do I re-reference? How do I re-reference this? Setup, set orientation, set horizontal reference. I wonder if these are... Okay, I could probably delete this. Oh no, but that's my remember we spent all that time like all right, well, that's gone. Okay, I saved it. We need a copy like this. Can we just copy this? Copy. Paste. Control V. Sketch. Back. Like that. .965. 2.965. Am I doing this right? You know what I could do? We could just take why Oh, this is sketch 18. Okay. We're going to need to. I'm sorry if you're watching this like in the future. Say flying cars come out. This is my thinking, right? Say flying cars come out and they're all based on like something I did or whatever. And I, for some reason in the future, am very famous and like Albert Einstein or something. Um, I hope Albert Einstein doesn't get canceled in the future, but say he is Albert, whatever. I'm thinking like people in the future will probably look back on this and be like, I wonder how Peter, blah, 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 made a blah, blah, blah. That's my thinking. Is like, say I do, say I do get like successful. Like Nikola Tesla in my time isn't even like, when he was when he was alive, he didn't get recognition for what he did. 1 inch. I should have known. Why would I make it anything random? If I don't have to make something random, I don't. Hold on, let's make like a little thing right there. But yeah, maybe someone will want to like look back and be like, I wonder how Peter, did the whole thing or whatever. Like, this isn't even. There you go. I wonder how Peter designed like the standard for how, flying cars look nowadays in the future or whatever. You know, um, Now I'm wondering, is this flat? Is this a flat surface now? From here to here, is it a distance? Yes. That means it's flat. Okay, so now we can continue from where we left off, which is right here. Okay. We need to take this entire thing, put it onto this flat surface. Okay. All right, we're back in business. Now that should be, looks like it It's a little crispy on the edges, but we can fix that. Let's start over because I didn't check to make sure. How is the future, guys? Does the future have flying cars? You know? You know how YouTube like recommends stuff like 18 years later? I feel like this video is going to be one of those. It's going to be like, "All right, let's see what it took to sort of, you know." Okay. So this guy and this guy, I think we can probably do like 0.1. Nope, other direction. Negative 0.1. Negative 0.05. Negative 0.025. Negative 0.025. Negative 0.02. This is not a precise math, but negative 0.01. Nope, other way. Negative 0.03. Negative 0.035. Negative 0.04. I think that's as close as you're going to get it. Let's commit. What the hell? All right, you know what we're going to do? By the way, this needs to get mirrored. We're just going to redo the work for this thing. Which really isn't that hard. 103.5, the new KTU. Do you guys listen to KTU? Oh man. I mean, is that still a thing in the future? My parents used to make me like listen to that. They didn't like put headphones on me and force me to listen to it, but like if we would take trips to New York or something, they would make me listen to it. I can't get this spline here now. Oh, there you go. Oh, no, I'm doing this wrong. I only need to do one side and then I could I'm thinking there's going to be a mount here, that's why it's square. All right. Hold on, let me. Mirror it. Mirror. Oh, sick. Okay. All right, we're back in business, boys and girls. So now, when I measure this to this, it should give me a measurement. Boom, baby. Let's go. 4.03. That's the magic number that we were after this whole entire time. Which would be easier if it wasn't so aesthetic, but you know, I gotta keep it aesthetic. So now this is going to be the sort of okay. See how it's like flat on the ground? Oh, this guy needs to be right there. Okay. So now if you look from the front, it's perfectly flat. Well, maybe not perfectly, but got to make sure it's perfectly flat. 2.7 inches. Oh, it's giving me a horizontal measurement. So I'm going to have to do a lot of cutting. A lot of cutting. We can start there actually, because that's going to need to be done. So we can take the distance from here to here. 6.01. Okay. Your price is way too high. You need to cut it. 6.1. Divided by 2. And I'm thinking like there. And just okay. That's too tight though. That's like way too tight. That's what she said. Probably like 3.1 or 3.2. And this guy needs to be like 1.5 or like 1.8. That's a pretty reasonable thing. Okay. And then just mirror that. See guys, anything is possible. You saw how much I just struggled. Just a word of encouragement if you're really in the future. And that's what's going on here. I didn't know half the stuff that was going on, but I just kept reading and trying different stuff and everything like that. And now we're here. Look at that. So yeah, obviously I need to cut out like I think that's pretty good. I need to cut like holes here. You know what I mean? That could be fun. Let's do that. Let's see. We do need a flat surface. Let's see from the tippy top. From here to here to the center of that is like that. But from here to here. So I need to split this into thirds. So I'm thinking we could start flat. We could start flat. So like this. Thinking maybe all the way up here. How big should the gaps be? 0.6. And then take this, mirror it. Okay. I see. Okay. So I know what's going on now. You see this right here? This is equal to this right here. This bottom piece. So we need to increase the gap here. Okay. So let's make it modular. Like 0.4. And then create what we had before, just with the new constraint. Okay. Now mirror this. And we could probably increase the gap to 0.6. And this to here is how much? 0.3. 0.4. 0.5. I'm thinking like 0.6. No, 0.5. And this one's coming from 0.5. And then this is 0.6. Okay, I want to make these a little bit bigger. 0.55, and then this 0.55. Or should it be 0.6? I think 0.6. I think 0.6. Let's do that. Okay. So now we have the trifoil, the patented trifoil. Okay. Yo. Don't knock it. All right, don't knock it yet. You know what it is? I think. What do you guys think? Because the propellers are pretty high up. You know what I mean? So the propellers won't be covered here. Because this guy is going to spin. Let me see something. This guy right here is going to spin like that. So, like, it's not totally protected. You know what I mean? Unless I do something silly. Take this guy, move him up. I don't know, to like there. But that will just be too, like, because then I'll have to move these guys down. You know what I mean? But then, you know, there will be protection. Because this guy is now underneath the duct. So let's try it. Let's try it out. I'm not against it. Let's try it out. It shouldn't take too long. From here to here, analysis 1.59. 1.59 plus 1.59. This guy, it's gonna look like a monster truck. Hold on. Let's see. We could probably increase this to like 0.8, or like we can increase. It's gonna need to be equal. So like 0.9, 0.9. Let's hope it looks good. I wish I had the back. But yeah, that's not that's not good. It looks like a monster truck. It looks way too it looks way too bulky. I think I'm gonna have to expose the propellers a little bit. I'm thinking. Um, let's just go back to the original. What was it? 0.6.6? I think it was. 0.6.6. And then minus like that. Yeah, I like that better. I like that way better. It's not going to be as safe. It's going to be a little bit safe. Um, did I say difted? You guys probably don't know what difted means. Huh. Okay, but I think we have 30 minutes left. Okay. I think that looks pretty good. If anything, I could make like wrap it with nah. I think that looks good. Damn, that looks sick. That looks really good. And then we'll need to create the well, Kevin Flum says we need struts in his song Mansion Tears. If you listen to that song, you'll see that because I asked him to make a song about flying cars, and then he dropped Mansion Tears like 3 days later, and it's like a UFO soundtrack and stuff like that. This guy needs to come down. Actually, what do you guys think? I think I'm gonna pretty much leave it right there, man. That took 2.5 hours, and that looks really, really good, Peter. This white thing is gonna need to, this cabin, I'm gonna need to create like Well, there needs to be cooling for the battery and stuff, so air cooling when it flies around. Man, that looks sick. Man, that looks good. From the back. Damn, that looks good. I'm gonna patent this. Oh my god. Alright, let me try to render it. Look at the how it's flat, bro. Flat on the ground. I outdid myself, I must say. You know what? The propellers are gonna be black. They're actually carbon fiber, aren't they? Texture, texture, image, carbon fiber. Carbon fiber propellers. Yo. That's how a flying car should look like. People are probably like, "Oh, it's really heavy. You can hollow this out." You can hollow it out. That is the sickest thing I've ever seen, bro. We did that, guys, together. You guys watched. I'm either gonna make this white, this like little gap thing white, or I'm gonna connect the propellers here, the wings. We could probably do that as like a finishing touch. I've been thinking about it, you know, because it's like, do I make it white or do I make it red? And I think the answer is red. So let's go ahead and go like this. Half an inch, I think. Or 0.6. Yeah, that's the right call. Um, mm, I guess we could do this one too. So sketch on here. Oh, whoa, whoa, whoa. Hold on. You know what's probably easier? If we create a datum plane like that, and then take this guy and mirror him. And then oh, 65. 0.066666. 0.068. 0.069. 0.07. I think it's like 0.0695 or so. We'll leave it at that. The 3D printer won't be able to pick that up. That little difference. It'll be our little secret. Yeah, I think that's pretty good. Why is there like a black thing here though? How did I make this? Oh, this guy. Oh, you know what I could do? Why didn't I do that before? It's 0.053. I could probably just do... I don't like that little square that was showing up. You know? And then just extrude this way. There you go. That squares away now. Much better. Kind of just killing time, I guess. I'm like doing checks and stuff. I guess what comes next is sort of the, cuz these guys, they fit. Like you can print this right now and it would fit. These bottom two. This one, well, I can't really select it, but this guy and this guy, they fit. But this guy has like a hole going through there, and that's a simple fix. Okay, so the thing is, this chassis is going to be sticking out a little bit. This frame, I should say, this arm. Honestly, I think that gives it a little bit of flavor. You know, it gives it a little character. But regardless, what remember we made this guy? We need this guy right here. This line right here. It gives, that's where the arm is. That's where the arm is, and then we're gonna need to make a hole. So if I take this sketch and how is this datum plane made? I think it was with respect to this. So take that number, paste it here. Oh look, we still have it. It's right there. Take that number. And then from there to there is from where to where? From the top of the airfoil. Oh no, that's not right. You know what we could do as well? Damn, we didn't sketch on that datum plane. I guess we can like estimate it by like putting a point on it. Oh, that works. If you zoom in enough, it's this number. That's the number I need. Okay. So here is that. That's the center. Okay. Oh, and look at that. There's actually a line there. So that's the center. And then we need like I guess we need like either a hole or a rectangle. And I'm thinking rectangle is probably better. I think we need like 2 by 1. .66666. Okay. Let's see what that does. Let's see where we're at. Remove material. So we found the center going this way, but we need to find the center of this thing right here. So this and we don't really have a line. Maybe like, hold on, let me hide this. This and this can create a line. Huh. This and I can't create lines on axes. I could do like you know what I could do is I could create just like a guide hole right here. Just like a very tiny .0001. What's the range? .00. Okay, .001. .01. So now that gives me an axis on it right here. So that and that need a point, which is right there. And then that point to this datum plane to this datum plane analysis. No. I can't do like point to. Oh, there we go. 8.6. But that's not what I'm looking for. I'm looking for I'm looking for from here, from the bottom of this to that point. .04. So from the bottom of this to the center of this should be like that. So we might actually get rid of the bottom. And then this should be 0. How's that? That's perfect. I just need this to be a little bit taller. So like, honestly, just give me some space. So like 1.4. Let's see. Okay, perfect. But I don't want it to be too wide, but I also want to make sure that top part is cutting in. We could probably extend this a little bit. Probably like to there. Okay. Oh, it's still cutting in. From here to here is how much? So like 0.02 or 0.013. 0.013 more. Okay, that did nothing. Okay. I'm thinking like this could probably be screwed in to that somehow. Like we can definitely utilize some of these holes. You know? That'd be pretty tough to do though. Because we have to think about mounting all this. But I am going on 3 hours. Um, But literally, I have nothing else to do today. Like, yesterday I got disturbed by someone. I like doing this, you know? And I can't really see. It probably doesn't need to be that wide. You know what? This thing could probably just sit right on top of the frame somehow. If I just add like a coupler here. Like, what am I thinking? Like a coupler assembly? One of these guys? Right? But instead of having this guy and this guy, I put that, wow, I'm a genius, bro. Literally, you just plop that on. Um, and then I would have to create like something like this that connects, that like extends out from. So basically, like create like something like this, copy and paste that onto this guy, and just have like a little, like a little, you know what I mean? Or no, it would have to hug it, I think. Thinking maybe we can extend from here and then what would that do mechanically? Mm, if I had like a from this wall out, right? And then just have holes and then it like sits on top and then it, but then what prevents this frame from like escaping? I guess the bottom part. Cuz if I have, the thing is, how am I even going to get a screwdriver in there? You know what I mean? How am I even going to like screw stuff in? I don't think this idea is going to work. You know? I don't think this idea is going to work right here. Cuz like how would, you know, how would the technician or the mechanic get his hand in there? Got to think about these things. Okay, so how would I mount this? Because the gaps are done. Like, there's nothing interfering with each other. It doesn't look like. That's hugging it. Um, You know, I was gonna pay someone like 50K to make this. I was like, bro, I would pay 50K for someone to make this, or more, probably like 100 or 200K, because I was like, how long is this gonna take? And this literally took me like less than a week. And like, if you do the math, right? I think I spent 7 days on it, times like maybe like 10 hours, 70 hours times 50. That's only $3,500 for what I have so far. And right now, for what I did, I would pay someone to get me to this point probably like 10 to 20K. Because $58 an hour, that's where I got 50 from in engineering hours. If I was working for a company, that's how much they would pay me. But if I was like a freelancer, to get someone to this point, I would charge them 10 to 20K. To complete it, 50K. So when it's tilting forward, it's going to look like that. This looks fucking sick, dude. I need to make sure, like, if my computer gets fried right now, which I hope it does not. Let's delete this. This is the one we're in. Just gonna save this real quick. Back it up to my hard drive. Extract. Rename. LA stands for Lorenz Aeroboticar, by the way. Nobody asked, bro. The drive. Hold on, let me do it up here. Why am I logged out, bro? Bro, why am I logged out? Lorenz. Rip. This is what I'm looking at right now. Upload. 4 minutes. 3 minutes. I think it's because I'm live streaming. It's taking a little bit longer than usual. 1 minute left. Once it's on the internet, like once it's on Google Drive, I will feel safe in my heart that all my work that I just did on the airfoils, on the winglets, is backed up. But it is 115 megabyte. It is 115 megabyte file size. It usually doesn't take this long. It's probably because I'm streaming or something. I don't know. What's my internet like? I have Verizon 5G home internet, so it's not that fast. It uses like cell signals, but it's cheaper than like cable. So I think we were paying like 150 or 180 or something for internet a month. Now we only pay like 40 or 50 bucks. But you get what you pay for. Right, guys? Come on, we're almost there. I'm looking at this right here. It's blue and complete. Perfect. Your price is way too high. You need to cut it. Man, that looks so decent. That looks sick. It's a little chunky in the front, but when you angle it right, like it makes sense, you know? It makes sense. Damn, that looks good. What were we doing? Oh, mounting, right. You know what you could do? I'm thinking like attach it here somehow. Or this coupler idea. No, not this guy. Coupler assembly. No, not coupler assembly. We need one that doesn't have this guy right here. Coupler. Oh no, we can't use coupler. We cannot use coupler. We have to create a new one based off of coupler. But just for example right now, okay, coupler, let's just for example, because you see how it has like this little aligning notch. Put it right here. If we just put it like right against this guy. Okay. We can reach it and then have like a thing coming off of here. Like this. I'll demonstrate it. So kind of like what was this number again? I X'd out of all of it. Maybe it's Oh, I have the number right here. Two. This is 1. Okay, so imagine like a sort of thing like this. Like something like that. Actually, I think it's going the other way. Like this. Okay. And then you have like a sort of like that. You see what I'm saying? Oh, I did it on this side. Hold on. Let me just put it on the other side. Constraint invalid. Okay, well, it doesn't have to be constrained. It could just be, but there would be a coupler here. Sort of like that. Wow, I got the dimensions right. But this clamp wouldn't be on top. But this coupler would be. And then I would have this arm here. That connects to this guy. He'd be pretty skinny. He'd be pretty skinny, maybe like point. No. I'd say like 1.4. Hmm. 0.7. Now, why is... You know what? Just gonna do it like that. Tired of these games, man. Tired of these games, bro. That's annoying. Here, let me create a dot here. And then let me create a center line from this dot. Okay. See, so he'd be kind of the same size as a coupler. While also having the shape of the tube. Run that back, Turbo. You know, I could probably just make this gap the same size as this guy. Analysis. What is this guy? 1.1. 1. Let's just do 1.2. 1.2. Okay. Oh, that's actually really. Oh, okay. And now. What does this look like? It's hard to see stuff. I'm not complaining. I'm just saying, like, if these were separate individual parts and an assembly, I could hide this stuff. But for now, I am just going to create a sketch and just hide it because this is in the way. And I could just undo that. Okay, there you go. Now I'm able to see. Okay. That's good right there. Oh, this guy's in the way too. There you go. Okay. That might need to come a little higher because there's gonna be screws here, like screw heads. So we can do that right now. This guy, extrude 11, could come up a little bit higher. I'm thinking like that. That could give the little screw head bolts room to breathe. Okay. Nothing's interfering with each other right now, which is good. Now, this guy can be pretty much the same size as this. So this guy can be pretty much the same size as this guy. Okay. And then this guy. Oh, here. Here we go. This guy can be all the way across, I would say. Well, actually, just pretty much to right there. Yep. And that could pretty much be to right there. And then this eclipse. Right there. And then like that. Okay. So that's kind of the idea. It's going to That's the other problem, is that that's pretty much the only spot that it's going to be mounted to. And in high speed winds, that's a pretty big piece to this is not going to fit on my 3D printer either. I'm going to have to split this into parts, which means these parts are going to be Frankenstein together. They're going to be screwed together. So I think I'm going to have to put another coupler right here. And then, how's the cabin looking? I'm really glad I cut out a spot for the cabin. Hold on, let me paint this all red so I know what I'm looking at. Okay. This cabin. You know what? I think maybe I could just put a piece right here, but then it would kind of ruin the airflow. I could put a piece that rainbows over this so that it has some support, because it's going to be supported on top with this whole thing. And then I could just put like a... I'm going to have to cut that off. Let's see. I'm thinking. Because if I put a coupler there, I feel like that's gonna. It's like that's gonna be too hard to take off if I want to take off, like, if I want to take this off in the future. structurally, do you think? Hmm, I think I'm gonna do it this way, which is like the way to create like a. That's not gonna be very strong though if you think about it. Mm, I don't know. What if I put a coupler there? Would it even fit? Of course it fits, man. I think of everything, bro. So I guess I would have to. I guess I would have to like create this whole piece, like this part, this guy. Like I was saying before, I think we have to span it across the entire thing and just let it sit. Because the thing is, though, the other thing is, though, this isn't going to be one individual piece. It's going to be split up. Like I'm going to print this one and then I'm going to print that one. So they're not going to be connected at all. But I do think it's true that we have to make it go like that. So we spent all that time doing that for no reason. Got it. I think that's, so you have some structural support. You don't want it to be flimsy. So you just put screws here and here. You shave all that off and round this out so it's kind of like one of these. A clamp top. It's pretty much what it is. Shave that off so that the screws fit. Make sure this is rounded around the tube so that it fits. We could start with the rounded tube bit. The tube is how big? Diameter is 0.393701. So we could do like 0.4. This is going to be difficult to see. I think we're going to have to delete or like hide this for a second. So just create like a rectangle and just extrude this way and remove material for now. Okay. I think the tube size was 0.4, right? I think so. 0.4. I just realized I was talking about the future because I was assuming that no one was watching, But I just realized that if someone is watching that right now, they probably think I'm crazy. Point 0.4. Now, this will kind of sit on the tube. Because I'm talking to people in the future. Alright. Is that good? See, there's a tiny gap. That's what we want. See that tiny gap right there? And then that is right there. Pretty good. Goes all the way through. Now that sits on there. Nice. Nice and tight. Nice and tight, bro. Now, we want this guy to be for some reason I can't constrain them like that. Oh yeah, I can. Okay, that's coincident. And now we could probably leave like a small gap here from here to here. It's 0.05 right now, so I'm thinking maybe like plus 0.03. Oh, we can make it exactly 4. Look at that. Let's see how bad you fucked this up. Just kidding. Right here. Analysis. 0.01. Cool. And now let's think about it. This guy probably wants to be either directly in the middle of these two guys, which I think is probably the right call. .01. And then get this guy and this guy. Okay, so plus 0.095363, and then take this and divide by 2. That's the number we're looking for. And then place this guy this distance, plug in the magic number, and now this gap and this gap are exactly the same, and we can check that because we just plugged it in 0.086 and 0.086. So now we'll do this gap analysis is 0.0142, and this guy needs to be extended .0142 minus this guy .0142602, 0.0153. So that's the magic number we're looking for. So plug that in here. Plus 1.65. Okay. So now that sits perfectly on. And then, you know that thing that we kind of hid? That's all going to be connected with like struts from like from the bottom here. There will be like holes here, and I'll connect like things, and that's why this needed to be so structurally sound, is because everything's going to be kind of hanging off of this right here. So there's going to be a total of... The thing is, I don't know how I'm going to get my hand in there. You know? I guess I don't really need this guy. I guess I need him for that, right? I need him for that, but we don't need this guy right here. It just hides it because it hides the whole assembly pieces. I kind of want that extra piece of structural support though. So we do need that actually. We might leave that empty because like in real life, like a mechanic can get his fingers in there. But me, I don't know. I'll leave it like that. It's pretty much the only solution we have. And then these holes from this are how far? 0.031. So right there. And then from here to here. No. No, from there to there. From there to there. It's 0.01. That's pretty much all we need right now. So from here to here and here to here are I think this may be that, and then this might be this. Let's see if that worked. Oh man, 2.2 millimeters to inches. Yep. Perfect. You can probably get rid of this guy. You can hide him for now. And then this guy and this guy are how far apart? 0.47. Okay. Point 0.47. And then we could probably take these guys, mirror them across this, mirror them, like that. Does that work? I mean, these are perfect, but these are not. They got mirrored too far. What's up? Good, how are you? We could probably take this guy and sketch. Huh. That should have worked. They're not like you see that little gap there? This guy. How far apart are these supposed to be? Analysis. 0.83. And what is this? 0.83. What do I have in my... Oh, no, they are. Hold on. Did I measure wrong? From here to here. 0.826. That's the number. So they're off by like 0.004. They're off. I don't think the 3D printer will care about that. I'm just wondering why that didn't like where in my logic did I go wrong? I did everything right. But anyways, let's round this out. Actually, before we do that, we're going to need to, from here to here, from here to here, this is the center line, I think, yep, and then just mirror all this stuff. Mirror across there. And that should align with these holes. Yep. Okay. And then we can create like what's 5 millimeters? Point. They snap into place, by the way. I didn't mention that at all. But they're all like the same size circles. You probably assumed that was the case. You're so smart. Okay. Enough dicking around. And then we could just curve these, I guess. You know? Something like that. Okay. And that'll kind of be the mount. The mount of all mounts. Right? I should probably back that up to my drive. Because if my computer crashes right now, I will want to die, bro. I'd have to redo all that. I need like a button to press to back up. Like back up to cloud, back up to cloud, back up to cloud. So I don't have to keep manually exporting. Copy. Delete. All export. This is it, right? I think so. Okay. And let me move this up for a second. Okay. It is backing up right now. We should be good. So now let's undo these sketches. Oh wait. This one and this one. Okay, and then let's take this guy. This guy. We need to mirror everything that we did. What is this? I don't know. But this, and this need to get mirrored across here. Why did it like delete when it did that? Maybe I'm doing too much at the same time. Okay, let's do one at a time. Okay, that's the tube thing. Those are the mounting screw holes. This is like that. And this is and then I could just round these guys manually. Oh, and these guys too. These corners. And now, actually, I should probably round this too. I was gonna delete it, but you know what? I might keep it. It gives it a little bit of an attitude. Damn, that looks sick. I could probably sell these kits, bro. I don't want to be a sellout, but I'm just saying this is like actually, bro. Bro. It's actually insane what's happening in my life right now, bro. I'm gonna need one of these aluminum tube. What about that? Aluminum tube, copper. Because these guys right here, like I said, they have this little notch in them. And they need the notch because these tubes, this one is 200 millimeters. And this one's 200 millimeters. So I created like a little connector here. And this thing connects them and holds them together. So that way, for the full scale, they don't make, I don't think they make tubes that are bigger than 1,000 millimeters, which is 1 meter. So I have to use 1 meter long tubes. I can't use just one single 2,000 millimeter because the supply chain doesn't have that. Oh, and it backed up. Sweet. So that's why it has like that little notch in it. So that means I'm pretty sure I have a coupler that doesn't have the notch in it. I think it's called XI coupler. Nope, that's not what it's called. But I could have swore I have one of those. I think it's called like X coupler. Yep, it's called X coupler. So I just need to replace, I just need to create an assembly because I don't think I have an assembly of that. So, what are those called? Winglet mounting assembly coupler. Winglet mount. So I can just grab this guy. And I guess here. And then coupler top. I think it's called clamp top. Oops. You guys weren't here when I made all this stuff. I made this like 9 months ago. And then I kind of I didn't have a place to build the flying car, so I kind of just, you know, put it to the side. Okay. So now that looks like an engine block or something, doesn't it? People were like, "Oh, you need to put X tension rods or whatever." I'm like, "Bro, I'm not done. Like there's things that are going to be on it that are going to like secure things in place and stuff like that." The only thing is this might move. No, it's not going to move because the other side, well, these aren't connected. These might shift around. No, they won't. Oh, actually, no, they won't. Because there will be a body here and stuff, so. Okay, so that's fine. Because there's going to be a cabin here, right? Where's the cabin at? Cabin. So this winglet will be hugged up against this guy. So yeah, there's stuff you can't even see on the underneath, like this you can see. But that work I did underneath, like this part, you can't even see that part. Which is typical of like a presentable thing. Man, I'm proud of myself. Let's see, what were we doing? What were we oh, this guy, coupler. Let's just get the distance. Oh, this guy's coincident. I gotta remember that. This guy's coincident. Oh, that might be tight, actually. Hmm. Because there's like 0 tolerance here. I didn't put any tolerance on that. Yeah, you know, I usually don't design with tolerances in mind now that I think about it. I mean, my 3D printer is very highly accurate. But I didn't. Like that thing in the back, I had some trouble assembling it. I'm not gonna lie. I cut some corners. Some stuff broke. I mean, like frame stuff broke, and it's not perfect. I suspect a similar thing's gonna happen here. And this is gonna fly, so it needs to be like FAA approved and stuff. You know? You know what? I could probably get away with this guy being shaved down a little bit. I could shave this guy down. And he got away with it. Oh my god. Oh, and the crowd goes wild. How much should we give it? Is this millimeters or... Yeah, this is millimeters. Alright, so let's say like 0.3. And now if we replace... Hold on. Why did aluminum get... X coupler and aluminum are literally the same file? What gets done to this one gets done to this one? I didn't know that. That's weird. Okay. Mm, okay, that's weird. I didn't know that. But XI coupler. Did I mirror it? Yeah, I did. It was 0.3, so now we have to do the same thing to these guys. To this guy. I just have to remember to, like, I need to be better about um tolerances and stuff, cuz I'm not going to lie, like I always have trouble with, like, cuz everything I ever designed was always with like zero tolerance. You know? I don't know what the tolerance on the 3D printer is though. So that should be okay now. Oh, this is an X coupler. Okay. Let's leave that. Let's leave that alone. And then delete this. And delete this. And then add, what did we call it? It's called motor mount. No, it's called winglet mount coupler, I think, or couple winglet mount. That's what I called it. Oh, wrong hole. Oh no, 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 no. Crap. Oh man, this whole frame moved. Let's try that again. What's 0.03? Okay, why'd you say it like that? Mm-hmm. And then we need a winglet mount coupler. We need a bunch of these, actually. You know what we could do? Instead of doing all that? Delete. Let's create a winglet, winglet full mounting assembly. Okay, so we're going to put the winglet. Oh, brother, this guy stinks. Why are you guys calling me names? not calling you names, bro. Okay. Now we can do couplet winglet mount. Okay. Except get rid of this guy. The top one. Delete. Delete. Please delete it. Not to be racist, but I love when Indian people go, please delete it. They pronunciate their T's like very extra. Alright, enough of that. Sorry about that. Not to be cringe. Okay. I have zero idea how I'm gonna fit my hands in there and screw all this stuff together. On a full scale, this would work, but on a small scale, I have no idea how I'm gonna fit my hand into there. Actually, this part won't be there at first. I think that should be fine. Okay. And then couple winglet again. That's pretty sturdy. I'd say that could hold up the entire winglet assembly. Okay, and then couple winglet mount. Okay, and then couple winglet. One more, guys. One more. Boom. Isn't this fun? I'm having a lot of fun. Hold on, let me orient this. And then let me make sure that I can see through the holes. Nope, I can't see through the hole here. Oh. Okay. And now I can simply go into here, delete this winglet from existence, make sure cabin is still there, and then winglet assembly, winglet full mounting. Put this guy on this pole, and then orient it to the middle of this guy. coincident. Oh, wow, that didn't work. Delete. That's not working for some reason. 0. Did that work? Let's get rid of the cabin. Looks like it worked. This is an expensive build, man. Yeah. Yeah, it is. But it's pretty lightweight, I would say. It's made of carbon fiber. These winglets, I mean, that's pretty thick. You could probably hollow this out. I wonder what would happen if you just press this button right here. Shell. That did not work. Or maybe it did work, but it's just too big. Maybe like 0.01. 0.02. Oh, it worked. It worked, guys. It worked. You see that? 0.03. 0.002. It worked, but it's too thin. This would not print. I could like butcher it up and like create holes in it and stuff. You know? This would be pretty thick, bro. It's gonna be a pretty thick piece. I wonder how long this would take to print. I don't know. Not worried about it right now. I could butcher it up before I print. But yeah. It's kind of the Lorenz style right now. How are we going to attach the cabin? I get this because this can just be struts. You know, you'll just have various forms of struts here, depending on the printer. Probably like a strut there. Probably like a strut here. No, front and back. And here, I think. I guess it just depends on how I split this up to print. Which I'm not worried about right now. But the cabin, this is kind of this is what the cabin has to be, like 100% has to be like this now. I don't think this is even oriented. These are constrained for sure. We can get rid of these. That blue line was probably irritating to some people. They were like, what the hell is that? What the hell is that? What the hell is that? Like the whole time. Thinking about making like a white extension. The thing is, are we done with the... No, we're not. We're done with the top, I believe. That's what I'm thinking about. If there's like anything else we need to do for the top other than butcher it to sort of make it lighter on the printer. We could like create a... The thing is, it is pretty butchered up already. You know, like we have this extrusion here. I'm wondering how long this would take to print. I don't know. We could check on cloud print, but that would take too long, and I don't feel like doing that on stream. I'd estimate probably like a day. You know? The great thing is I don't have to print the chassis. The chassis, other than the little pieces, like these little things right here, but I could literally do that all in one shot. Like just print a whole bunch of them and just freaking grab them off the printer. That would be sick. These all can fit on the printer, like literally every single last one of them. I think that's it for today. It's 1:26. I've been streaming for 4.5 hours. I don't know where to place the struts because I don't know about the printing situation. So we kind of have to leave it like this for now. They're not even going to be really struts. They're going to be just like holders. Cuz struts physically this doesn't like, you know, cuz this thing does not do that. Plus metal is heavy. Like if you put struts on a real car, it would just have to be like right here, this guy. You'd have to split this into different parts and then put like a hole right here. And then you know, create like a connection thing. That's what I'm talking about when I say struts. I'm talking about like a connector between the two parts. One part could probably be enough to hold the whole thing. It would just have to be pretty thick. And that's pretty much it. And then we have to worry about LEDs. I think LEDs you can probably just, like, they come with a sticky thing and you just stick them on. So you could probably just line it, like line the bottom or something, or the inside of it where the propellers are not hitting. So like down here and like, yeah, like that, like just one LED strip all the way around. That would be pretty sick. But yeah, guys, that's pretty much it. You saw me walk through the winglet design. Um, I don't know. I don't know when I'm gonna do this part, like the back. That's gonna be a whole another episode. But this is looking pretty nice. I'm gonna end the stream. Like and subscribe. If you watched at all, I appreciate you. Thank you for coming to my stream. Pretty exciting. I think this is history in the making. Last time I did not live stream myself CADing, and then I came up with that, but this one I feel like is so much better, especially because it can actually fly. So thank you so much for all your support. Oh, you know what I have to do? I have to worry about the cabin coming down. And then the wings will kind of... The wings will probably end around here, and then I'll bring it down like that. It's gonna look really, really good. It already looks so good. This guy at the hacker space was like, you know, you're competing with the Roadster, right? I'm like, yeah, I know I'm competing with the Roadster. You guys think this competes with the Roadster? Be honest. On a scale of 1 to 10, 1 being doesn't compete and 10 being beats the Roadster, demolishes the Roadster, 10 being demolishes the Roadster. What do you think this is? Leave a comment letting me know. Like and subscribe. I'll see you guys tomorrow.